So hi everyone, this is Andre Bossart speaking. I want to show you or introduce a little bit to the example code that I will provide you for the presentation I had last Friday. And the first file we will be looking at is called bad but clean.java. And you know, like the clean code book has quite some good principles and ideas, but I think the examples in there are not as good, and I want to explain to you why. Let me improve a little bit the size so I'm sure you'll see it. So let's start with like the overall and a quick overview about this class. It's called setup teardown includer. It has a public render method and it's with a default parameter. So it has like an issued additional parameter that you don't need to specify, and then it's taken as false. Okay, so this is the whole public interface, and the rest of the class is all private interfaces. So that's already telling us something. If a class has only static public interfaces, you can be pretty sure that there's no need to have instance members, except of course if you have a cached instance of this class. But as you see here, the very first command or the very first statement is to create a new instance of this class. So there's no reason to have any instance variables there. The whole code, the whole setup of this class could be purely static. Okay, so what does this setup teardown includer do? The constructor, it gets some data, it accesses some of the properties of the page data that is accessed to it, and then from this test data it gets a property and initializes a new string buffer. Okay, initializing a string buffer and getting these references, I mean, that's not something special. Not using any kind of additional memory, it's really cheap. And then it does one thing, it calls the render method and it's returning the result of that. So let's go to this render method and we see it's already here. And there you see like it unravels, like there are multiple layers from this class that you need to go down to see what's happening. And you see it takes another instance variable, because only here it receives this issued parameter. And you see, depending whether is test page, whatever that is true or false, it does something else. And then in the end it returns this page data get HTML. It's really interesting. So if test page out of any reason is anyway false, it just calls get HTML on the page data. And now you need to think a little bit that maybe the whole approach of this class is wrong. You know, like you don't need a special render method in a class to call get HTML. So maybe let's add a little bit of room here. So like if this page data has a get HTML method that is the same as this render method of this weird class, then why not just have a teardown wrapper, teardown wrapper apply page data, and then this applies a static method that does whatever is required to apply and returns again a page data, and then you do a get HTML on it. So just a small example on how it could be used as well, because yeah. Anyway, then we go into the next layer and we see is test page has depends on whether it has the attribute test. So already here we are down 2 layers and check for the existence of an attribute, which is then used here. And then if it's yes, in this method you see what's happening, and it does calls this for other method. And of course it's trying to tell a story, but the story is really cumbersome to read, and now it's a very simple story and it's already cumbersome to read. But imagine if there would be more branches here, or imagine if one of these teardown pages or one of these methods would actually call one of these methods again, you know, like this kind of calling private members on yourself. If it's used like completely linear, it's easy to understand, of course, but it's also useless. And if it's not used linearly, then it's really hard to follow what goes on in the code. Anyway, so there we see finally someone is picking up this issued, and the funny thing is that's really early in the process. So if it has the attribute test and issued is magically true, then it calls this include suit setter page and executes kind of this step. Yeah, I think it's really intransparent what goes on, because this guy, for example, does not know when he will be called, and only if you like look up where it's called, you know that it's part that issued is required. And only when you check where this is used and then check where this is used, you get an idea that it's only applied when is test page is used. So in this super simple example, it's making it much more complicated to figure out what's happening. And then, well, you know, like all these methods have like 1 or 2 lines, and they're basically doing something probably important, like with this include. Please also, yeah, read my comments that I put on the file if you want to. But it makes it really hard to understand, for example, when is update page content being used. So you need to search for it, and then you see it, oh, it's the last step of this include teardown page, and then you need to search again to understand, oh, this is only used when is test page is true. And then luckily it's just here, but hypothetically you would need to look again when is test page true again. So I think it's maybe the most cumbersome way that you can structure a class. And now with complexity in mind, and as a little bit of a reminder, complexity, oh yes, complexity here. How hard it is to understand and change the system, okay? So I think like it's hard to understand and change it comparatively to the really simple task that it's actually doing. So let's look at how I would rewrite it to make it simple to understand what's going on. So first thing is, there's only 2 methods. One method is this public method that has the same interface as it has before. For brevity, I removed the one with the default parameter. The other method is a mix of a method that was in the previous class as well, but this time it just returns a string, so it's not doing any kind of modification of the page content. And now if you look at the render method here, it's immediately clear what goes on. So if page data has this attribute test, then this whole block is executed. And I think that's a sensible block size, because it's not that big. You can easily read it and understand it. And maybe there are people who argue about like, oh man, but you know, like so many lines of code and you need to go through to understand it. Well, that's true here, but here the difference is you need to scroll much more, and there's like 3-4 times the amount of lines of code, and most of them are useless. They're not adding anything to the system or the solution. And you see there's no instance variables required. There's not a single instance variable required. And not only that, the string buffer, for example, only needs to be used in the special case that page data has the attribute test. And then you immediately also see where issued is used. You know, it's used on 2 occurrences to add the suit set down and tear down, and yeah, and the string buffer is not passed around like some kind of weird things that get modified, but actually is only used in the scope of this function. And then instead of replacing the content of the object that has been passed to, which is really bad because it modifies, oh no, sorry, wrong place. It modifies the parameter, or it modifies the object that was actually passed to this render method initially. So here it's not doing that. Here it creates a new, well, let's say fictional page data with this content, and it calls getHTML on it to return a string. So what do you think? Like, which version do you prefer? The one where you immediately see what's going on, or the one where you have like 5-6 layers of stuff going on and you don't see what actually goes on? For me, the decision is simple.